In today's video, we'd like to show you the amazing agility that CrossVista's SmartBranch platform introduces in the DevOps world. Here we can see is a project that's representing a branch tree going from production to SysInt to central development. So it's our branch tree pipeline from central development all the way to production, covering in this case 2 different technologies. So IBM's webMethods cloud I/O integration, as well as IBM I/O API platform. Yeah, so covering server components across those technologies from production all the way to what we call the central development. As well as we can see there are some 5 child branches out of central development where we have a series of developers working on feature branches as well as bug fixes. So me as a release manager and the owner of the project, I can see all of the components. But let me now log out. I log out as a release manager, and I will log in as a first developer to then show you what happens once we start doing changes. So we go. As a developer, you can see the developer has only rights to actually contribute into the central development. What code moves up from the central development up to SysInt and production is how the release manager, the project owner, then sets up and what requirements is done, either in CI/CD or not. We'll see that as we go along. So in here, the developer has, and for this feature change, he has to work on a service called feature one service. So let's go down to the development platform for IBM's I/O integration. So let's find out the service is this service here. This service we go in, and let's go and do some change here. Transform pipeline. Let's basically try and add here something where we go into the math and select the service, maybe add floats, and add floats. We basically go and add something here. In that we put a number, just to add some code here. It's not important. We just need to do some change to actually produce a code change. We click on save, and we go save the service. Once the service is saved, so we go back to CrossVista's platform. As a developer, I can go and find out the changes I've done in my development tenant. So CrossVista, because it contains the initial revision of that service in our SmartBranch repository, we now detect as a change to that object. We can go and commit it here. We can actually even see exactly what change we've done. So we added a new step in that integration service flow. In that case, we have basically adding a new math add floats. That's fine. We can go and commit our code by then selecting the ticket that was given to us to work on. So it's a feature one change that we need to go and do. So we can go to the M6 ticket, but it's a feature one change. So we go and commit that ticket to CrossVista SmartBranch platform. So the commit is, so we have to detect the change and then commit it. So it's done. And now, so either we are happy with it and we can move forward, or if we're not happy with it, we can go back to the development farm, do some more changes, commit again, and so forth. So we can actually do some kind of an intermediate change as part of our development activity. In this case, we want to actually say and signal to the system that basically all of our work for that ticket is now finalized, and we can actually go ahead and say, hey, we've done our work. So what we will see in a second is basically the system itself has reacted to our signal that we signal from the feature one branch that our work is ready to be integrated, and the system itself basically pushes our work, and basically you see the blue line is now disappeared because my work is now being integrated into central development. So let's log out, and in this case, let's actually go to developer 5. The developer 5 has been asked by the release manager to work on a bug fix. That's this bug fix 2. The bug fix 2 needs to change, as you can see here, has to change a service called UI child. So let's go back there. Let's actually go here as well. And the UI child, DU child is this one. In this case, let's say that we want to do something again. So let's do something here easily as well to start with. Very quick code change. And here as well, do we have comments? We outputs, save. Doesn't matter, just a code change. The code change that we do is independent of how then the system reacts. Can be very simple, can be very complicated. It doesn't matter. And if we save that, we can go back here in the same fashion as before. We also do our check sync. And in the same fashion, it goes red, indicating there is a change between the live system and the version of that object, of that asset that we had in CrossFit SmartBranch repository. We can also, again, like before, just open and see the changes that we might have done here. Yeah, we have a change, and we go ahead and commit it. In this case, it's not a feature change, it's a bug fix, the bug fix 2. We go ahead. It's just a different ticket that is associated with this, called here on hotfix 2. So work is committed. We could automate that when every commit it's integrated to move up as well. But sometimes at the end of the day, we do a commit, but we're not ready to move the code up yet because we might continue working on that. It's almost like a temporary save of the work as well. So in this case, we're going to signal that can be moved up, and as we can see, the central development branch that basically has a gear appearing, basically signaling there is some work going into the central development. And I know exactly what's being moved on is the change, the revision 2 of the DUI child that's been moved up from our bug fix 2 branch to the central development server. So it's gone. So let's go, and last but not least, let's log out. Let's go and log in as developer 4. And let's see what developer 4 suddenly realizes and sees. Basically, developer 4 is working, and we can see what is working on, is basically going to work on a service called uParent. However, CrossVista is managing, so as part of the object representation as well as the unified representation we have, we manage dependencies and references of all the code that we have. So we can see that this new parent is dependent on a service called uchild, yeah, and is dependent on the uchild's revision 1 of that service that we have here. And what we can see here now is that he's been warned by the central development that there is a new version of that DU child is now revision 2, and you have a dependency into revision 1. So you can go and do your changes in your parent service, but you won't be able to move your code until you basically do something about that conflict. You can still move any other code without having any problems with that. So how can we show you that? So basically now I can actually go out and log out from this user and log in as developer 3. Developer 3 that potentially has to go and work on a different feature. Yeah, feature 3. We can see it, feature 3. So we can see there's nothing yet changed on that as well. So let's go back there. And so in feature 3, so that's this service 3 here. Let's go and change that quickly. And let's very easily put here just a transform pipeline, and that's it. Let's just transform pipeline. It's just one single step. We'll save it, we'll go out, and we go ahead, check live sync. And like before, we detect a change. We can commit it. Again, we can show you the change we've done, just add that step in our service. We can go and commit it to the branch. We select our ticket. Feature 3 is that one. We go ahead and commit it. Of course, in the background, we're also updating the ticketing systems with all the required information as well and all that. It's committed. We can go ahead and set the branch to integrated. Say yes. And like before, we will see a gear appearing in the central development that's basically moving our code from the feature 3 branch into the central development branch. and it's done. So we can go and log out, and let's now go ahead and log in as the sort of project owner, release manager project owner, and see what happens here in the system. Yeah. So what we see is when we have the full picture of this is that all the code that we had in feature 1 to feature 3, as well as bug fix, have now moved to central development. What we can see here as well is that we see a gear in the sysint, basically making code available. So there is some integration from central dev into the sysint. We can see here as well what it is. Actually, it's no longer there because it's already moved. Yeah, it's already moved. We could go and actually show it to you as well, but the branch is full green. Yeah, the branch is full green. We can actually even go and run it by running a check sync. It compares the status of the branch with the live system, and that will show us that everything that we have in that branch is actually in live system as well. We also now see there's one arrow going from sysint to production, and now if you click in there, we actually will see that we have the hotfix 2 as well as the other tickets, the 6, 7, and 8. So for the features, so 1, 2, and 3, yeah, and they got moved automatically to central dev and to sysint. The only thing that now is blocked is that bug fix 1, but potentially the release manager knows that hotfix 2 is more important. He can just go ahead and say, hey, let me do one thing. I would like to go and integrate the branches, but I can integrate the branches by tickets and by so there's an high priority to actually move that hotfix 2. Yeah. So we could have set to go to production. We could also go ahead and move stuff automatically, like we moved from the child branches to central development and from central development to sysint in a very CI/CD fashion. But normally to go to production, it requires a different set of users, a set of approvals, or a different set of priorities. And in this case, the release manager wants just to move, first of all, that hotfix 2, because it is more important and was required to be moved. You can actually even see, so that's the ticket associated here, and we can go ahead and move it. And as it's moving, potentially the developer 4 might be then working on addressing that problem, that conflict. Developer 4. And now would he be addressing that? So there's some code moving there, so we'll see about that later. So we go here and say sync parent collision. And say, okay, let's see what I want to sync. I want to update my branch with a new revision of that service. So we just go ahead and do this. So it should be in sync. It's actually synced. And now we can actually go back to development. In development, I can now go change what I need to do for that new parent. And maybe we'll go ahead and here just enter a comment for that allow custom message add custom log, done, save, done. We go back here, check live sync. So as usual, we see the change that we've done. Yeah, just adding the custom message, and we go ahead and commit it. This case is our bug fix. And the same, set branch to integrated, say yes. And the same will happen that in a second, as we see, the central development gear appear on that branch, basically saying that there's new code being moved from bug fix 1 into the central development. So the agility demonstrated here is unique to SmartBranch. Two different technologies were managed as part of one process. This could work the same regardless of the combination of technologies being used. It could be on-prem, SaaS, or serverless. It doesn't matter. No scripts and workflows were used. You could see what was being changed, what was being moved, how it was being moved across Vita's SmartBranch repositories, but also the live systems. But my personal favorite is how the CRM, so conflict-driven release management DevOps approach, enabled CI/CD with added benefits. We showed how we proactively identified a conflict and indirect conflict at that, with no merger required. We identified and resolved the conflict without maintaining the organizational structure and independence of each feature and fixes. This meant we could deploy individual features and fixes or all of them. No need to manually edit a single script or workflow. No other DevOps tool on the planet can do this. Thank you.